You would probably imagine a star sitting alone in space and glowing peacefully, as most people do. But the universe has other plans. Out there, almost every star is stuck in a gravitational relationship that makes human drama look boring. And this year, things escalated. Astronomers captured the first direct image of two black holes orbiting each other in real time. Not a simulation, not theory, actual black hole binary caught in the act. Hi, I'm Lopa. Welcome to the world of astrophysics. Here we talk about the universe. The algorithm pushes noise at you all day, but if you chose to click on this instead, then stay. Let's learn something real today. By the end of this video, you'll know why binaries dominate the universe and why astrophysics keeps returning to pairs like it has an addiction. Let's begin. What even is a binary? Two massive objects, one shared center of mass, a gravitational dance they cannot leave. Simple idea but extreme consequences. Their orbits are rarely calm. Most binaries don't trace perfect circles, they follow stressed ellipses. Every orbit has two modes. At periapsis, they are closest and gravity goes wild. At apoapsis, they drift apart and everything relaxes. The semi-major axis sets the system's energy. Shrink it and everything speeds up. Stretch it and the dance slows down. This would be the clean two-body problem, except real stars cheat. They expand, lose mass, steal mass, explode, collapse, or straight up merge. The equations try to keep up and end up filing for stress leave. Now let's see how many types of binaries are out there. Star-star binaries. These are common and chaotic. When one star grows into its Roche lobe, gravity stops pretending to be polite. Material spills over into the partner's territory, forming streams and accretion disks. Push them closer and they share their outer layers, forming a single peanut-shaped envelope. Cute from a distance, a thermal nightmare from up close. White dwarf star binaries. These are cosmic landmines. A white dwarf steals gas of its partner, and if it steals enough to cross a critical limit, it detonates as a Type 1a supernova. These explosions shine so predictably that they became our rulers to measuring the universe. Standard candles born from stellar theft. Neutron star binaries. This is where the universe gets violent. Two collapsed cores orbit so tightly that space-time itself starts to vibrate. When they collide, they send out gravitational waves and forge heavy elements like gold and platinum. Every ring, every coin, every piece of gold you have exists because two dead stars collapsed billions of years ago. Black hole binaries. These are the loudest mergers in the universe. When they fuse, they release more energy in a few seconds than every star in the observable universe combined. That's what LIGO detected, space time ringing like a bell. But the first clue came long before LIGO existed. 1974, the Hull-Stellar pulsar. Its orbit was shrinking exactly as Einstein predicted. Energy was leaking away through gravitational waves. Indirect evidence decades before we could catch the waves themselves. Einstein still undefeated. One more twist, binaries can literally bend and magnify each other's light. It's gravitational lensing but more chaotic. Now let's go to recoil kicks. If a black hole merger is uneven, the final black hole gets launched away at thousands of kilometers per second, fast enough to escape its entire galaxy. Imagine a galaxy losing its central black hole because the merger was slightly unbalanced. Now, in 2025, the historic image. Finnish astronomers captured the first direct image of two black holes orbiting each other. The system is OJ287, nearly 5 billion light years away. One black hole weighs 18 billion suns, and smaller one is comparatively small but still massive. The smaller one completes a 12-year orbit around it. This time, we aren't modeling the orbit. We are literally watching a black hole binary. And yes, it happened 5 billion years ago, but the light is reaching us now. Planets around binaries? Yes, planets survive this chaos. Kepler found circumbinary planets, worlds with two suns and two shadows. We have discovered 14 planets with two suns. Imagine standing on one of them. Just mind blowing. Binary systems build modern astrophysics. They gave us supernova, gravitational waves, heavy elements, cosmic distance scales, and the earliest test of general relativity. The universe doesn't work alone, it works in pairs, and almost everything we understand about it comes from watching what happens when two objects orbit, collide, and rewire physics.